Hey guys, how's it going? So today actually we're gonna be going through toolformer source code, including the paper. So I feel like this video is gonna be quite good. I'll make sure that I explain each line of code. Uh, Honestly, today I'll try by all means to link these code to the research paper. So I'll make sure that by the end of the video you understand, right? So you see these equations, I'll show you how we implement them using PyTorch, and I'll make it so much easier that you understand, and I'll link each line of the paper to each line of code, right? So this way you get to understand these functions in PyTorch, you will understand what they do and how we subset and all of that. I'll definitely make sure that you do, right. So if you don't understand by the end of the video, you can dislike, but I doubt you will dislike because trust me, by the end of this, you will understand toolformer and you will understand the source code, what's going on, and each line of code. So that's that. But I just want to say that I just want to apologize for my previous videos. I feel like the audio was quite bad. I got a message from Vishal. Then he told me that actually the audio is quite bad for some of the videos. So I like to apologize for that. I feel like I have ordered the new mic, which is gonna come, and so videos in the future will be much better as we go on. So yeah, so we're gonna start with the research papers from Telforma. Then what we're gonna do is that we're gonna get into the code. So, but if you wanna see me talking about the code, then you can jump to after 20 minutes. You can jump and go there. Then that's when we're gonna get into the code detail and we're gonna link everything and explain everything in much more depth. So check it out. Anyway, without wasting any time, let's get started. Before we jump into the code, let's just have a high-level overview of the toolformer architecture. So essentially, we can think of like you have a data set, right? We can think of this as going from I, like these are input tokens from I all the way to N. And at each position, at each I, we can make an API call. That's a candidate for us to make an API call, right? For instance, here we can make an API call and we can get output if we execute that API call, okay? So we want to keep only the API calls that are actually going to minimize our loss. So anything that does not minimize our loss, does not necessarily help us, we're gonna discard it. Okay, for instance, here we can see that the right answer should be still city, but we got United States. That means here this we're gonna discard this. Hence here you can see our final data set that is augmented with data with APIs. It's gonna keep this API call. Like it's gonna be QA. What is other name of pizzas bag known by, right? And we get this output which is still city. Okay, so before I continue, I just wanna raise some annotations that you're gonna see a lot. For instance, the CI here is going to be representing positions, API candidate positions. That these are where we can make API calls, right? Then another thing is that you're going to see a lot is these notations. So these essentially simple. These are special tokens. So they tell us where we start an API call and where the API call end. Okay, then we have another special token. You can think of this as like after we've made an API call, then the response. We have to have the response there, right? So for instance, we can see here it's used this and we have the still CT and this was the API call, okay, with the input to that API call. Okay, so yeah, but those are the main annotations. But anyway, now let's get into the meat of this paper, which is the sampling API call, right? So without reading anything, the high level overview of this is that you can think of like we have like input sequence, right? Within that input sequence, we want all the positions that actually we can make an API call. So you can think of like we have a probabilistic model in which we're gonna give it a prompt and the sequence of like tokens, right? Then it's gonna tell us like the positions. What's the probability of making an API call at that position, like position I? Okay, So how you can think about these input that we give to the model, like prompt, for instance, is just this thing here. So we leveraging the fact that these models have what we call in context capability. So we can tell them that you ask to add an API call, and we make an input and we make an output. For instance, here we show it an example and get an output, and it's just going to do that for us. Okay, so that's what we do. So but the gist here is that now we have the probability of at I, right, us making an API call. So we want to filter these by a specific threshold. We're looking for very, very good positions that we can make an API call. Then we're gonna keep those I position, right? You can imagine that if it happens that we have more than actually more positions, then we're just going to filter them by selecting only the top k. Okay, that's what this is to this sampling technique. So now I just want to explain that from the code perspective. So let's get into the code. So before we get into the code, I just want to walk you through the file structure. I think the code might be overwhelming, seeing a lot of files, but they're actually quite simple. So we have this folder here called data generation. Essentially, you can think of these files here. They're going to help us augment our data set with APIs. And the reason there's so many of them is because of they are catering for different tools. Like we can have a calculator, calendar, something like that. But really, when you understand the base API code, you're gonna understand all of these files. Okay. Then we have this folder here called data handling. You can think of like now we have generated the data for all these different tools, but we want to combine these data set into one, and we want to send that data set to Hugging Face so that we can train our model. So this code is going to do that. Then we have this train GPTA model. So this is where we're going to train our data set augmented with API. So we're going to do all of that inside this code, right? This is all it is. We're going to cover these, and you're going to see the interdependencies between these files as we go on. Now, coming to the sampling API calls, we're using this function called filter continuation. So we can think of this function as like we have the probabilities as explained in the paper of like each position. These positions are candidate that we can make API calls. But the first thing that we really want to do is that we just want to remove all the start tokens because we want to consider other positions. In this case, how we do it is that if the start tokens equals to label, we're gonna set these to true, but we're gonna subtract them by one, so this is gonna equate to 0. So the things that did not like equate to true, meaning that these are not necessary start tokens, they're gonna equate to 0, but when we subtract one, they're gonna give us 1. So in this case, when we multiply their probabilities, the the start tokens here like will be set, their probabilities will be set to 0 because we do not want to consider them. Okay, I hope you understand this code. So anyway, we have this maximum probabilities. So essentially we want to say, given these probabilities, we want to know that um, at the specific start token, right, we want to get the maximum probabilities, right? So we can think of here, we're going to get the maximum probabilities of all the start tokens, right? Then we're gonna multiply this. This is just so that we remove the tokens like that are gonna be the start tokens here. We don't need this. We're just considering other positions. Then we're going to let me just zoom in. Sorry, let me just zoom in. Yeah, thanks. Anyway, we're going to use this top k function in that we're going to select like the top k positions, like meaning that the top uh, positions that are we can make an API calls, right? So we're using this top k function, and the top k here is going to be 5. So the top k values is going to be 5. But really, to visualize this in a much more better way, let's look into the paper, right? So how you can think about this is that given this input token and this input what is it? Input 10 tens, right? It has multiple positions, and we have these positions, right, that we can make API calls. In this case, in the paper, they selected 5. So you can think of like CI, CI2. We have these are all the positions that we can make an API call. Okay, so that's what we do. But how do we then get this text here? For example, what other name is pre-spec known by? So we already have these positions. We were able to generate the positions, but now we want to generate this text, right? How do we do that? So we need some sort of like a decoding machine. So is that if we given some sort of like input, it can continue and generate this, right? So this is going to be like more like an input to the API call. Okay, so I think this is also written here, if I'm not mistaken. They state that for each position I, we then obtain up to M API calls. This is going to be from CI to CM by sampling from M given the sequence. So the sequence consists of like the input, which is going to be prompt, and the sequence, right? And the start of the API. So from given the start, you just need to continue, right? Can we see something like this in the source code? That's my question. I think it's actually written within this function, which is called create candidate. So this comes after the function that we covered, which is filter continuation. So this create continuation, how it works is that it's going to go through all the indexes that we generated. Remember that in the previous function, we generated the top k indices. So we said that those are potential k for us to generate API calls. So how will this work is that we just need to say that given the input token, right, starting from the input like the start of the token all the way to index, right, we just need to take that as input and add this start token. We can think of this as a start token. For example, something like this here. So this is like a calendar. We have this bracket here. Like I told you, this bracket, don't forget it. It always gonna mean the start of the token. Although in the paper they denote it as API, something like this. Okay, but in the code you're gonna see it like this, right? But essentially what we're doing here, you can see that I am interpreting this essentially as like the prompt, right? And the input, like the start input and the all the way to the index, right? And the start token. So then the model will need to continue to generate from here. So where is that happening? It's happening here, right? We call this generator that, okay, take this text to test and please generate for us the sentence with max of the new tokens that is going to add is going to uh, add up all to 28. Then these are going to be 5 sentences. Okay, so that's how we generate that those sentences that I just showed you now in the paper. Okay, but we skipped some of the code. If we go up, the some of the code that we did skip here. Okay, so how I'm interpreting this code is that, okay, we have the input tokens, right? Then we have from the start of the input, like this is gonna be the input start, right? Then when we pass this input token, so this model is going to return us some sort of like logits, but we want to keep the logits from the index all the way to index plus m, right? This is because I am thinking that let's say we have like some text here like GPU. I just think of something random. GPU is cool, whatever, right? So let's say we have something like this. So we can say that essentially from index to index plus m. So thinking that, okay, this is the original text. So this is the text. We did not make an API call, right? We did not make an API call at all here. This is like the original text. So we want to say that, okay, this is where we are making an API call at I index, right? At I index. So we are removing like this thing here. We're gonna cut here. We're gonna cut call, right? So we are removing this here. So I'm just gonna remove this GPI. So we are remaining with this call. So you can think of this as index to index plus m. Then the reason we're doing this is because we want to calculate the loss, right? This is because we want to see if like what is the loss of us not making an API call. Does that make sense? So we are going to compare this like index That's why here from labels also we're taking from index to index minus one. So we're going to compare these. So we're using this criterion. This is essentially cross entropy loss function. Okay. So some of you might be, yes, but why are we getting the loss? I think it's because, I think also in the paper they did mention this, it's because of we're going to use the loss to actually see if like this is actually helping us. Like we want to compare if like making API call than not making API call, which one is good? So let's go back to the paper. I think just so that I don't confuse you. So this step here, you still remember the step? So we want to see if like we want to filter API calls, like making API call. Does that help us? Making not making API call. Does that help us? Something along those lines, I think. Okay, so that's my intuition why we needed to save this. Okay, but that's what it is to this. Essentially, here we're thinking of like we have these candidates like of positions, and then we need to essentially generate text, right? And we're gonna see then how we move forward from there. But just to take you back also from the paper, so we just generated this text, but in this manner here. So you can think of this like we have like these brackets, that token, then this question here is gonna come inside here. Okay, that's what I think we're gonna do. But we haven't yet executed the API. We haven't yet executed the API. That's what we're gonna get into now. Let's go back to the code. So for us to understand how we need to execute an API, we're gonna have to use this function called add API call, right? But because of this API, here we're using a base function, so we need to go to another file like called calendar, right? We can go to any file like calculator, lemchang file, retrieval, any file. They are the same. In this case, we're just going to use the calculator. The code is literally the same, like, right? It's just that they adjusted for different tools, but literally you can look into them. They're the same. Hence, this case, we're going to use a calculator. But at the high level, we just need to call an API, right? So let me make an example. So in the previous function that we spoke about, which was the what is it, create candidate, we spoke how this works, right? So I'm just going to make an example so that we don't forget as we go on. So we can imagine that the model generated something like, this is like the start of the API. Then maybe here we have like, what is the date today? Something like this, right? What is the date? So we expect the model to call the calendar API so that it can get the today's date, right? That's what I'm talking about. So now let's go to the model. Let's go to the calendar so that we see how this is actually happening. Okay. So when I get here, the first thing that I'd like to do is to introduce you to the imports. So we have this thing called tools. So if I go to tools, it's just a code with functions that implement all the tools that we need. For example, calendar is quite simple. It's just going to use this calendar and get the day name, get the month name, get the year and all of that. So that's what this thing does. So it's just going to say today is and get that information for us. So the model has to know when to call this by its own. So that's why we train in this, right? Then we have this retrieval. You can go all of these things. We have like Wikipedia search, all of these. You can use them, but in this case, keep things simple. We're using calendar. Okay. So the question now is, what does this add API call does, right? What does it do? Like, what is the main thing about it? So at the high level, without looking at the code, what I can say is that here we are essentially trying to generate multiple multiple text, right? We're trying to generate a text that has an API, right? API call, and we're trying to generate a text that has no API call, and we're trying to generate a text that has an API call, but it does not have a response, right? I know I might have confused you there. For you to understand this in a much more deeper way, we're gonna have to go back to the paper so that you can actually be able to know what this does. Okay, so what I'm gonna do, I'm gonna go to step number, I'm gonna explain these two because I feel like they are quite dependent on each other. So for you to understand this, I'm gonna have to explain also this filter API calls, right? So what's gonna happen on filtering API calls at the high level without reading? What I can say is that here we have multiple APIs and we want to filter them. But to filter these API calls, we have some sort of like loss functions that we calculate, and we have some sort of like a threshold that they have to uh, reach so that we can select them. So what's going to happen is that we can think of like we have a loss functions. This is a loss function, right? Given this, given this API call and the response, right? What is the loss function given this, right? And then we're gonna say what is the loss function of like having an empty, like nothing here, right? Like not making an API call at all. And what is the loss of like having an API but we do not have a response? Let me repeat. We have a response of an API. What is the loss? Now we come to this. We say we do not have a response. We have empty. What is the loss? So it's like the model has generated, but it did not call an API at all. Here we say we have an API name, right? But we do not have a response from that API. What is the loss? We take the minimum of this. So now we have these two losses. And what's the threshold? The threshold is that this subtract this must be greater than threshold. So how you can interpret this is that the minimum of us making the minimum of the loss, like of like not having any API call, and then also like a loss of having an API name but not having a response, subtract the loss whereby we have a response and an API name, that should be greater than the threshold. Okay, that's the filter that we're going to use for filtering API calls, right? Why is this important? Why am I telling you that? It's because this code here that I have to explain to you now, is quite important, because you will see that this code essentially, we are trying to say, we are trying to essentially create, without looking at the code, let me explain to you. We are trying to create like different inputs, like the ones that have an API call, the ones that do not have an API call, something like that, right? That's what we're doing here. We also making, we also like making like input that have an API call and response of that API call. That's why we imported this tool here, because we're gonna have to use it. Okay, so we're gonna have to use the self calendar. Okay, so how this works is that we're gonna store the generated text, right? This generated text is the generated text from the previous function that we spoke about. So we're gonna extract it from here, right? So this code here, I'm not gonna get into this because these are just like cleaning. I just want you to understand the high level and the core of the paper. But here we're just removing, I think, the candidate. So I think these are prompts. So we want like the calendar, like the API tokens. I think that's what we're doing here, right? But anyway, nevertheless, what are we doing here? My point was that we are going to create this calendar text in which we're gonna pass it this empty calendar here. So we can think of this as like, we are constructing, base inputs in which they're going to be having this API call name, but they do not have an input. I repeat, they're going to have an API call name, but they do not have the API output. So it's the same thing. Let's go back to the paper so that you get to understand in a much more deeper way. So this is what we have. So we're gonna have to have they're going to have an API name, but they do not have an input, right? That's what this is going to do. So we call this base. Remember that for now. Okay. So that's what this is going to do. So we get the that we pass these into a tokenizer so that we can get the input IDs. Okay. Then the next step that we're going to do is that we're gonna have to call this calendar function, in which we're gonna pass the calendar string. So this is gonna be, I think it's gonna be a date. Then we're gonna get this. Let's go to tools. We're gonna get like this thing here. Today is all of this, right? Like we're gonna get the date. You can think of this as gonna be stored inside here. Okay. Then this will be also saved into the calendar text. Then here, this is going to be test input. So we're going to take this and we're going to store it within this calendar text, right? That's what we're going to do. Okay. Then we have this text input and the base inputs. So we start all of these things here. I know that you might be saying that I'm skipping some of the lines of code and you might not be happy with this, but really, like, the thing of what I'm trying to do is that I'm trying to explain you in such a way that you understand the objectives, uh, then you understand like the goals, something like that. Because like if I get into this, like I will confuse you even more because now like so I want to explain to you in such a way that like you have a deep understanding, right? So just bear with me. Trust me, I'll try to make it easy as we go. So this is we have the text. Don't forget we have the base input in which we can see that we have this API call name, but we do not have a response. But we have these text inputs in which we have these calendar text, right? And the calendar text we can see that we have these are uh, uh, API output, because this calendar here, we're executing an API here, right? We're storing it inside this calendar. So and we're gonna concatenate it with this. So you still remember this sign? This sign, we saw it in the paper. So it's when like we have this the API call starting and ending position, then we're gonna have this output, right? And we're gonna close that. Then this is gonna be assigned to this text input, right? So that's that. Then we're gonna return this generated text, and we're gonna return the max token and the max token length space. Okay, so things will make sense now. Things will make sense when we come to this function. This is generate continuation. So what will happen here is that we have the input tokens. We pass it within this filter continuation. We covered these things, we know what they do. So I'm just passing all the input and we're getting like the top k indices, and we pass them inside this create candidate. We covered this function, we know what we're gonna get. Then we just covered this API calls in which we have this generated text. Okay, so this is where you're gonna have to understand in a much more detail. So what we're gonna do with this is that you still remember this text inputs. We need to pass them now inside the model. So we're gonna get the text output. We have this base. You still remember this? We're gonna pass it also inside the model so that we get the output. So this is what we're talking about here. So we had this text, right, in which we said the text is the one that has an API call, and we said the base is the one that did not, right? So don't forget that. So we have two things that we get the logics of these two things, right? Let's go back to the paper so that you don't forget. Where is the paper? There is it here. So we know that we need to somehow get the minimum of like us not making an API call, like it's just like pure response, and having the name and no response. And here we have the response, right, and the API call. So we have three things. This one, you still remember this one? Probably you say, I know this is the text, this is the base, but you didn't see this one. Yes, you saw it. It was here. Let me remind you. Uh, so before we get into this, I just want you to know all of this stuff first so that when we get there, so you still remember this create candidate, you still remember this loss, it was here, right? So it was the loss whereby we did not make an API call. So you see, calculate loss without an API call. We did not make an API call. You still remember this loss? Yes, we covered it when we covered the second function, create candidate. And we did actually save it within the outputs. Okay, so we have three things, just like the paper say here. Where is it? We have three things. We have where we make the API call, okay, and we get the response. We have where we're not even making an API call at all. It's just pure text. Then we have where we have API call name, but we have no response. Okay, you remember those things. Okay, cool. Now that you know those things, we can say let's go back to generate continuation function, right? So we pass these things. We pass the the test inputs into the model. We get the logits. We pass them inside the model. We get the logit. Then now this is gonna be our threshold. It's gonna be the best loss. So we know that what we need to do is that we need to take the minimum. uh, where is the minimum? Yes, this is going to be the minimum here. So right, so it's going to be the minimum of the base and the minimum of the generated text. So it's the same thing in the function. So it's the base and the minimum of the generated text. This subtracted by the text loss should be greater than the best loss. So what does this mean? The base is gonna be where we have an API call name, right? But we did not get a response. Then this is gonna be what is it? It's gonna be where we did not make an API call at all, right? So we take the minimum between these and we subtract by the test loss. So this test loss essentially means that we did make an API call and we got the response. So this equation should be best than this, right? Then we're gonna keep that. So this is going to be the best. You see, we keep in this. So because of its greater, so we need to keep. So this is the best output and the best loss. So we keep this, right? Just like they said in the paper, right? I know that you might be saying, why am I skipping a lot of code? It's because of, to be honest with you, like I'm not skipping code. I'm aligning what I'm aligning all of these things to the paper so that this way you get to understand in a much more deep way. Because if I try to like explain like dimensions like this, like I feel like I'll confuse you because I'll try to be more specific, then you might actually forget the high level architecture and the objective, right? So if you want to learn about dimensions and all of that PyTorch, like check my previous video about pre-training. I try to explain in much more detail. Okay, so I hope you understand this, right? So now you might be asking yourself, what is the next step then? So the next step will be model fine tuning. So we can think of like we have the data set and we are happy with this data set because the data that we generated is giving us like good results, meaning that we know that these APIs calls that we generated, like they have a better loss, right? Like right, they helping us to predict. So we need to fine tune the model, right? So that's what now we're gonna get into. So for us now to fine tune, we're gonna need the data, right? So we know that this base API or these files that we covered here, like the calculator, they generate the data for us, meaning that we have this data here. It's just like the data set augmented with like API calls, right? But really to store the data and save this data inside a file, we use this file for called data generated calcs. So we are literally using the same code. in which we're gonna call this calculator class processing, and we're gonna pass in the model inside it, right? So we're gonna pass the model, the data, and the tokenizer. Then we're gonna get this data output. We're gonna save this data output inside this calcs data, right? As a JSON, right? We do all of this for calculations and LLM chain, and we do this for retrieval, and we can think of like we saving this data for all of these tools, right? Then we have this folder here called data handling, in which these files are just for examining the data. It's not necessary, it's just like some plots, but the key the key file here is going to be this, in which we're going to open all of these data set, right? For from different tools, and we're gonna have to combine this. We're gonna call this data combined data set, and we're gonna dump this data inside the folder, right? Um, what are we gonna do with this data set? We're gonna have to send this data set to Hugging Face. So this data set will be pushed to this account on Hugging Face, right? So we're gonna take this data set. The reason we're doing this is because when we pre-train, we can actually point to this data set on Hugging Face, right? So we push this data set to the hub. Okay, so this is the pre-training code that we gonna be using. Actually, I'm saying pre-training, but fine-tuning um, code. I think Concept of Mind said that this code he actually took it from the Hugging Face run clm.py. Then he's using the same pre-training code that they did use, right? So if you really want to understand how like fine tuning and how pre-training work, check out my previous video, which is called the pre-training of La Llama. And if you want to understand fine tuning, you can check out my alpaca video, in which I explain how we do this stuff. And I also was using on the alpaca, I was explaining the Hugging Face code. So uh, if like you can understand much better. But that's that. I feel like the meat of this paper was um, was really trying to understand like how everything was brought together. But I personally think, I don't know about you guys, I personally think that this paper, if like it was like written like in April, it was gonna be different, um, mainly because things have changed, right? A lot of people are using ChatGPT to generate the data, right? Like ChatGPT can pretty much generate the data. Like if you give it this, it can do an extremely good job. Check out my alpaca video. I explain the same thing here, like and I show how ChatGPT has done it. But I have to say thanks to Concept of Mind. He has done exceptional, brilliant job trying to really like execute everything in the paper and going extra miles and all of that, right? That was quite incredible. So yeah, I think this paper, if it was implemented today, it would have been done differently. Like for instance, I think the ChatGPT was going to be able to annotate the data set and all of that. Then the thing that I think was going to be quite critical was the inference part, in which when you have generated the data and you have fine-tuned a model, now the model has to like call an API on its own. So you're gonna have to like make sure that you interrupt the decoding part where you see something like a token like this, so that you can go and make an API call and continue decoding, right? That's like the trick that you're gonna have to add after you have implemented the model. I think the inference part, like you just need to make sure that you interrupt it and make an API call based on the model prediction, then you would have done it. But yeah, I'm pretty excited for this. This was quite good. I really appreciate it, guys, for watching. If you did actually enjoy and understand some of the stuff, please like and subscribe. I don't usually ask, but like since I'm taking this serious and I feel like I have to, it's gonna motivate me to keep on going. Thank you, guys. I'll see you in the next one. Bye.